In this lesson, we're going to take a look at Newton's second law, work an example problem, and define what a Newton is. So first thing, what is Newton's second law? Well, Newton's second law says net force is equal to mass times acceleration. That's how I usually write it. You could also say acceleration is equal to the net force divided by the mass. Now this law actually kind of makes a little bit of sense when we think about what mass actually is. Remember, mass measures inertia, and inertia is the tendency of an object to resist acceleration. And so we can see in this equation, if the mass is increasing for a given force, the acceleration will go down, right? As the bottom of that fraction gets bigger, the whole thing goes smaller. So acceleration is inversely proportional to mass because mass resists acceleration, but forces are what cause acceleration, so it's directly proportional to force. So as the net force acting on an object gets bigger, so does its acceleration. So mass measures inertia, inertia resists acceleration, force is how big the push or pull is, and a net force causes an acceleration. Now, forces are measured in newtons, at least for us. Force is measured in newtons. Now, 1 newton is by definition the amount of force required to accelerate 1 kilogram at 1 meter per second per second. And what that means is 1 newton is equal to 1 kilogram times a meter divided by a second squared. That comes right from this law, right? I take mass in kilograms times meters per second squared for acceleration. But that means you have to pay attention to units when you're solving problems. If we're given force in newtons, then mass has to be in kilograms and acceleration has to be in meters per second per second. So sometimes you'll get mass in grams and you'll have to make that conversion. Make sure you do that. Okay? So Newton's second law, it's an equation. It's going to be one of the tools that we can use to solve problems. So let's go ahead and do that. Let's work an example problem. So if we have, say, 17 kilogram, let's go 10 kilogram. If I have a 10 kilogram block is pushed right by an 8 Newton force and 3 newtons of friction acts on the block, what is its acceleration? Like always, we're going to start with what we know and solve for what we want. So let's get our list of given information, just like we always do when we solve problems. So we're given a mass of 10 kilograms. We have a positive force, because I've chosen to the right to be positive, of 8 newtons. And we have a negative force, because that frictional force is opposing the motion or the intended motion, of negative 3 newtons. And we want to know the acceleration. I'm going to draw a free body diagram. It's a good habit to get in. This problem probably doesn't require it, but we'll have some problems that have lots of forces, and it's good to label your forces. So there's the center of mass of the object. I've got this 8 Newton force acting to the right, and then I've got this little 3 Newton frictional force acting to the left. Now, gravity is also pulling down, and the normal force is also pushing up, but those two balance each other, so I don't really care. And so now I can say the net force is equal to the sum of the forces, so I can say 8 plus a negative 3, which equals 5 newtons. And if I want to solve for acceleration, acceleration is net force divided by mass, so I can take 5 newtons divided by 10 kilograms, and that equals 0.5 meters per second per second. So this is a straightforward problem because we were given mass and 2 forces. Sometimes you'll be given displacements and have to do some kinematics to find an acceleration and get a net force. But we're going to be adding this tool to the things we can use to help us solve physics problems. And do be aware that that says net force. We did have to find that. I didn't use 8 or 3. I combined them to get the net force before we solved the problem.